discuss those. I mean, before we start doing a problem, we'll wait for 5 minutes for doing that. Other people have any questions? Anybody is tried plotting these wet bulb temperature lines in humidity chart?
Yes, sir.
Yeah,
I wanted to ask about that only.
yeah.
How
Ask,
to plot
ask.
the wet bulb temperature lines.
How to plot means you just
Like using the Antoine equation or the other this equation, right? The humidity.
this this your wet bulb temperature is the wet bulb temperature related to is the wet bulb temperature same as Antoine equation, or wet bulb
No,
temperature gives the relationship between temperature, humidity, and the wet bulb temperature, right? This relationship is coming from heat and mass transfer, right?
yes,
From wet bulb means mass transfer from wet bulb to air and heat transfer from air to wet bulb, isn't it? So this
yes,
equation describes our relationship for wet bulb temperature for any temperature and humidity of the air, isn't it? So this equation we need to plot on this humidity chart. Is that okay?
yes, sir. Got it.
And have you seen humidity charts, Ansh?
Yes, sir.
Have you?
I've seen some charts, and I even saw a program in MATLAB.
Yeah, okay, that's nice. You can do that. And anyway, I showed you these charts last time. We will start doing some calculations based on these charts now.
Excuse me, sir.
Yeah,
Sir, could you give us an idea about the mid-sems, like till what, like all the portion that we'll be having, and will it be MCQ or written?
yeah, mid sem it will be portion will be till whatever we do till mid sem. That is mid sem is on 12th July, right? So whatever we do till next week, all that will be the portion,
Okay,
and
sir.
it will be through Google Classroom.
So it like the Google form, like MCQ, which we were having
It
previously.
might be that, it might be writing some things.
Okay, sir. Okay.
Why do you worry? You have to anyway solve a problem, get the answers, either write the answers or select tick 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 tick, isn't it?
Yes, sir. Yes.
That way this subject is very simple and straightforward. You just have to do material and energy balance, that's all. And energy balance we have not done, so you just have to do material balance, that's all. I think you will like solving mid-sem exam. It will be interesting, to say the least. Beyond that, I cannot say anything. Okay, I think let's get started. Many people have joined now. Others will slowly join. We can't wait for Ram to join because he would be having his breakfast. I don't know whether he has joined. Ram has joined. So then that means everybody is ready. All right. So what we'll do today is just do some couple of problems that we did last time or in the previous classes using humidity chart, right? So for example, we had this problem. We had input ambient air which was at 35 degrees centigrade, dew point at 30 degrees centigrade, and total pressure was 760 mm Hg. and we wanted to heat up this air to a temperature of 80 degrees centigrade. Total pressure was 760, right? And percent RH was 5, right? Let's try to do this using our humidity chart, and let's see how easy or how straightforward this problem becomes using our humidity charts. So this was RH equal to 5, and what I had asked you to do is what kind of process would you want. That was the problem that we did, right? Do you recall this problem?
Yes, sir.
Right. So first of all, if you just want to look at the input air, temperature is 35 degrees centigrade, dew point is 30 degrees centigrade. Let's look at that in terms of the humidity chart. So this is, now let me share the humidity chart as well. One second, let me share that. Yeah, are you able to see the humidity chart? Are you able to see the humidity chart?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. So our temperature is 35 degrees centigrade. That means this is okay. Now let's zoom in a little bit. Okay, so this is 30, 32, 34, 36, 38, 40. So 35 is here, right? So we are somewhere along this line, 35 degrees centigrade line. And our dew point is 30 degrees centigrade. That means if I cool this air, water will start condensing at 30 degrees centigrade. That means the humidity must be such that if I cool that air, it will become 100% saturated at 30 degrees centigrade. Therefore, the incoming air must be having this kind of composition. Do you agree with that?
Yes, sir.
So the humidity, if you read from the right hand side y-axis, this is 0.02, and this is in terms of kgs of water vapor per kg of dryer. Let's just check the units. Yes, it is kgs of water vapor per kg of dryer. So if you just extend this point to the y-axis, right, that point would be somewhere here. So we would be something like point. So this is 0.02022468. This will be nearly 0.028, 0.027, 0.028 kgs of water vapor per kg of dryer. And the other thing that we wanted, the outlet air was 80 degrees centigrade. So if you go along at 80 degrees centigrade, if you go from here along 80 degrees centigrade, we had 5% RH. That means we would be somewhere here. So this is the outlet air that we want. So this outlet air would have a humidity something like this, right? So 0.01, 0.12, 0.14. So outlet humidity would be something like 0.015. Inlet humidity would be something like 0.027. Okay? And if you had at all wanted a wet bulb temperature, these lines are the wet bulb temperature lines. So if you look at the incoming air, if you wanted the wet bulb temperature of that incoming air, so we are at here. So this is going along this wet bulb temperature line, right? So this is the wet bulb temperature is 30 and 35. So this is 31 degree wet bulb temperature. And if you are looking at this condition, 80 degrees centigrade, 5% RH, we are along this wet bulb temperature line. We are along this wet bulb temperature line. So this is the wet bulb temperature, TWB and HWB. So this would be 34 degrees wet bulb temperature. Is that okay? Is that clear? Can you do it yourself now with the chart, with the help of the chart? Yes, no.
Yes, sir.
Okay. So let's go back to our problem. Right. Let's go back to our problem. So this humidity here would be point zero, whatever one, whatever value was there. What was the value? Do you recall? Anybody recalls? 0.27. Right? It was 0.027, and this H was 0.015. This wet bulb temperature, if you wanted wet bulb temperature, this would be 31 degrees centigrade. This wet bulb temperature would be 34 degrees centigrade. Do you recall that? Is everybody clear? Should I
Yes, sir.
repeat anything? Can we
Yes,
move
sir.
forward? It will help if
Yes,
you
sir.
open a chart yourself and then do this for yourself, do these calculations for yourself. So obviously now the humidity has to reduce from 0.027 to 0.015, right? So what are we going to do? We would need to cool this air. Let me stop this again, go back to the chart, right? So this is our inlet air, this point, and this is our outlet air. Correct. So we would need to reduce humidity from this value all the way down to this value. So the way we are going to do that is if we can condense water out of it. How do I condense? We have to cool to its to below the dew point. So the dew point is at 30 degrees centigrade. If I cool, now temperature will reduce, humidity will reduce, right? We will keep on cooling, we'll keep on cooling, we'll keep on cooling, we'll keep on cooling, we'll keep on cooling till we get to the required outlet humidity. So the required outlet humidity is 0.015. So that means we will keep on cooling, and because it is below the dew point, water will start condensing as we go, as we cool along, as we cool down from 20 degrees, from 30 degrees centigrade dew point, 35 degrees centigrade temperature of the air, we keep on cooling, we reach the dew point 30 degrees centigrade, right? We are going along this blue line, we are going along this blue line along, and now we are cooling. As we are cooling below 30 degrees centigrade, water is simultaneously condensing out and the humidity is reducing until we cool to 20 degrees centigrade. That's the place where we will want our air to be, because it is meeting the required humidity. And now we will take this 20 degree centigrade air which has cooled, and now we just condensed out water in the liquid form. We will separate that water. Now the 20 degree centigrade air, which is at 100% such relative humidity, but it is having much lesser humidity, 0.015. Then we will heat this air to our 80 degrees centigrade, and then we will have our air which is at 80 degrees centigrade and 5% RH, right? So what we are going to do, what we are going to do is, let's go back to our problem. Yeah, so what we will do is we will cool to 20 degrees centigrade, condense out liquid water, separate out that liquid water. The air coming out will be at 20 degrees centigrade, 100% RH, but it will have humidity of 0.015. And then we will heat that air to 80 degrees centigrade, and that will make the humidity 0.015. It has already reached that humidity, but it will make the relative humidity as 5%. Do you agree with that? So how straightforward this problem becomes once you start looking at it from a humidity chart angle. Do you agree? Do you disagree?
Yes, sir.
Anybody has any doubts? Anybody has any issues? Anybody has any doubts?
Sir,
Can
can
we?
you repeat? Sir, can you repeat once?
Can I repeat which part? Which part do you want me to repeat?
How we decided that we have to cool to 20 degrees centigrade? That part using chart.
Okay, how we decided we want to cool to 20 degrees centigrade. Okay, let me go back to the chart. Right, this was our chart. So forget about all this, right? What are we doing? What are we doing? This is our inlet air, 35 degrees centigrade and 30 degrees centigrade dew point. Do you agree with this, that this is our inlet air?
Yes, sir.
Up to here it is okay, comfortable.
Yes, sir.
This has a humidity of 0.027. Okay. Do you agree that this is our outlet air, 80
Yes,
degrees
sir.
centigrade, 5% RH, which has a humidity of 0.015, right? Do you agree with this?
Yes, sir.
So that means we need to remove water from this air. We need to remove the water vapor in order to make it go from here to here, right? This is the path that we want to go. This is our inlet and this is our outlet, isn't it?
Yes, sir.
Do you agree that this is where we want to go? This
Yes,
is
sir.
our source, this is our destination. Now we need to remove water, right? What are the options that we have seen for removing water? One is either cool below the dew point, or second is we cool, second is we pressurize, increase the total pressure. But then I will have to have chart at different pressures, right? So right now that's not the path that we are taking. Now I have to cool below the dew point. It means first I have to reach the dew point. So from 35 degrees centigrade, if I start cooling, I will go here. Do you agree with that?
Yes, sir.
Now, so the air will become 100% saturated at 30 degrees centigrade, but it will have a humidity of 0.027, isn't it?
Yes, sir.
I don't want that humidity. I want 0.015. So that means I have to cool. Cool means what? I have to go towards the negative x-axis. Means I have to go along the x-axis in the negative direction. Do you agree?
Yes, sir.
So that means we want to travel in this direction. But is that possible? Then air will have more than 100% humidity, relative humidity, isn't it? So that means moment we start going below 30 degrees centigrade, water will start condensing out. Water vapor will convert into liquid water, right? And as we cool to 29, as we cool to 28, as we cool to 27, as we cool to 26, as we cool to 25, water will become water vapor. Some of the water vapor will condense and become liquid water. Humidity will reduce, but the air that is remaining will be 100% saturated. Do you agree with that?
Yes, sir.
So now is 25 degrees centigrade. If I cool to 25 degrees centigrade, is that okay? No, it is not okay because it has a humidity of 0.02. My target is 0.015. That means I need to cool further. So 24, is that okay? No. 23, is that okay? No. 22, is that okay? No. 21, is that okay? No. 20, is that okay? Yes, because now I have reached the humidity of 0.015, which is what I require. Do you agree? So we are
Yes.
going like this. isn't it? We are trying to cool the air like this, okay? And the amount of water that is condensed is here. That much amount of water will condense. So we can't go here. Air will automatically go along this 100% saturated relative humidity line, because the remaining air, because water is condensing out, will always be 100% having 100% RH. Do you agree? Now we have reached the air with the humidity that is required, and we have got liquid water which has condensed out. This much amount of liquid water has condensed out. So that condensed out water we will separate. Now this relative air we will take, which is at 20 degrees centigrade, 100% relative humidity. Now we will heat that to 80 degrees centigrade, because in heating the humidity is remaining the same. There is no water being added or water being subtracted. Do you agree? Is that okay?
Yes, sir.
Can we go forward?
Yes, sir.
Anybody has any doubts? Om, are you comfortable now?
Yes, sir.
Okay. Anybody has any doubts? Any other point? Shall we go forward?
Yes, sir.
So here is one more problem. Okay, let's call this as, say, problem number 4. We are doing many problems than just problem number 4, but I think in basic calculation itself we did 2-3 problems. Achha, anyway, other question that I wanted to ask was, these 3-4 problems that you did you do them with the humidity charts? Any difficulty in those? Let's just take the last 2 ones, or we saw that perhaps, right? Or you want to see them again, or we saw this, or you've done this. Last 2 ones where we had to do lots of trial and error calculations and non-linear algebraic equations. So did you do these 2 problems using humidity charts? Yes, no? Somebody say something. Did you try, or you want time to do now using humidity charts?
So,
Yeah,
could we solve it now?
yeah, solve it now.
Okay, sir.
So just do these last 2 problems. TWB is 20 degrees centigrade, percent RH is 50. What is the temperature, what is the dew point, and what is the humidity? And second is temperature is 40 degrees centigrade, dew point is 20 degrees centigrade. What is the humidity, what is the percent RH, and what is the wet bulb temperature? Do these 2 now, and we will see the solution in the using humidity chart. There are two humidity charts, one at low temperature, one at high temperature. So use the proper chart. If you just do Google, you will get humidity charts. They are there in your textbook as well. Himmelblau is our textbook. First one, shall we start doing? Or you need more time? First one, shall we do? First one, shall we do? Or you need more time? No answer means
Sir, we need more time.
no answer means more time. So this is the low temperature chart. First problem is wet bulb temperature of 20 degrees centigrade and 50% RH. TWB is 20 degrees centigrade and 50% RH. You just have to read from the chart. Use the low temperature chart for the first problem. And even second problem you can do with the low temperature chart. This is one. Second one was temperature is 40 degrees centigrade, dew point is 20 degrees centigrade. Temperature is 40 degrees centigrade, dew point is 20 degrees centigrade. Both these problems you can do from this low temperature chart. Who would like to volunteer? Somebody would like to volunteer? Moment I ask someone to volunteer, some 3 4 people leave the class. I don't know what. Just a coincidence or Ankush?
Sir, sir, I got the temperature and humidity. Sir, can you tell how to find dew point here?
Okay, Ankush. Let us look for a volunteer. Ankush, are you there?
Yes, sir.
So would you like to do these problems on the using the humidity charts?
Uh,
Say something, Ankush. Yes or no?
So I'm still confused.
Oh, so all the more reason you should volunteer. Okay, so Ankush, tell us. First one you want to do, second one you want to do.
So I'm not started it.
Doesn't matter. So we will start do it together. Ankush, are you there?
Yes,
You're
sir.
listening?
Yes,
Got
sir.
all three, sir.
Ankush, you are listening or not
Yes, sir.
listening?
Sir, listening.
Ankush, very nice. So what does the first one say? Wet bulb temperature is 20 degrees centigrade and 50% RH.
Yes,
Can
sir.
you can you identify the 20 degree centigrade wet bulb temperature line on this humidity chart? Are you able to see the humidity chart on the screen?
Yes, sir. Yes.
Yes, you are able to see. Right. So where is the 20 degree centigrade wet bulb temperature line? Can you tell? Ankush, say something.
Yes, sir.
Can you tell me where the 50% RH line is?
Sir, how should I? Sir, it's means 25 degrees Celsius and
25 degree centigrade. nahi re baba.
no, it's in that line.
So 50% RH line is this line. Do you agree with
Sir,
this?
yes, sir. Yes, yeah, that's something.
Right. Now, where are the wet bulb temperature lines? These are all the wet bulb temperature lines, right?
Yes, sir.
Ankush, do you agree?
yes, sir.
So where is the 20 degree centigrade wet bulb temperature line? Which one of these is the 20 degree centigrade wet bulb temperature line? This one. Do you agree?
Yes, sir. 293.
Correct. So this line is 20 degree centigrade wet bulb temperature line. This line is 50% RH
50%.
line. So that means our air would be having this composition. Do you agree,
Yes.
Ankush?
Yes, sir.
Now what is the humidity? I just have to go to the y-axis and read what is the value.
Yes, sir. It's about 11.5.
Correct. About 11.5. What is the unit?
Sir, kg.
Unit is written here.
Yes, sir.
What is the unit?
So gram kg
Grams.
per.
Gram kg nahi, it is gram per kg.
Yes,
So it
yes,
is
sir. Sorry, sir.
humidity would be 11.5 grams per kg of dry air. Right. If you want to write in terms of kgs per kg, I will have to just divide by 1000. This would be 0.0115 kgs of water vapor per kg of dry air. Right. That is
Yes, sir.
one. Now what else did we want to find out? We wanted to find out dew point. Dew point would mean what? I take this air and keep on cooling. Cooling means in which direction would we go? Left, right, top, down. Cooling means temperature will reduce. Means from here we will go up, down, left, right. Which direction?
Left.
Left.
Sorry, sir.
Ankush,
Left. I just
uh,
kept my off.
left because other people are answering.
No, sir. I just kept mic off.
No,
So
no, don't keep mic off. You are volunteering, so keep it
no,
on.
sir.
Doesn't
It's just background.
no, let there be background. Let there be background, but you be in the foreground. That's all. So if you cool at this temperature, once you reach it, air will become 100% saturated. It will have 100% RH. Do you agree?
Yes,
And
sir.
then water will start condensing if I cool it anything below this temperature. So this is our dew point. Do you agree with this?
Yes, sir.
So dew point, this is 15 degrees centigrade, this is 16 degrees centigrade, this is 17 degrees centigrade. So maybe dew point is approximately say 16.5 degrees centigrade. Do you agree?
Yes, yes, sir.
Right. What else do you want? We want temperature of that air. What is the temperature of that air? This is the point where we have 20 degrees centigrade wet bulb temperature and 50% RH. This is the actual dry bulb temperature of the air. What is the value here? This is 25,
It's
26, this is
27,
27, this is
28. Okay.
20, yeah, approx 28, this is 29, this is
28
30,
degrees.
so 28 degrees centigrade. 28 degrees centigrade. Do you agree with this?
Yes, sir.
Ankush, are you comfortable now?
Yes, sir.
Now, second problem, you will volunteer for the second problem as well. So don't keep your mic off. Keep it on. Let there be background. Background noise doesn't matter. Second problem. What is the second problem? Here. Temperature is 40 degrees centigrade. Dew point is 20 degrees centigrade. Now identify this point using this humidity chart. Temperature is 40 degrees centigrade. Dew point is 20 degrees centigrade. Identify this chart. Identify this point and tell us where to go, how to go, what is the point, what is the humidity, what is the wet bulb temperature, what is the percent RH. All these three things you have to tell us: humidity, percent RH, and wet bulb temperature. These three things are required. Temperature 40 degrees centigrade. Dew point is 20 degrees centigrade.
Yes, sir.
Ready, Ankush?
Yes, sir.
Yeah, tell me. I'm listening, Ankush.
Yes, sir. 40 degrees.
I can't hear you, Ankush. You need a couple of minutes, Ankush, to think about it.
Yes, sir.
Ah, okay. Temperature is 40 degrees centigrade. Means where would we be? Temperature is 40 degrees centigrade. Means we would be somewhere along this line. This vertical line would be 40 degrees centigrade line.
Yes, sir.
Okay.
The,
Now, if I'm going to be somewhere along this line. If I'm here and I keep on cooling this air, air will become 100% saturated, and water will start condensing out at this temperature, isn't it? If I am
Yes.
here and I cool, water will start condensing out at this temperature when it becomes 100% saturated. If I am here, I cool, air will become saturated and water will start condensing out at this temperature, isn't it? So if I'm here, the dew point is this 617 degrees centigrade. If I am here, the dew point is 10 degrees centigrade. But what is my dew point?
20 degree.
20 degrees centigrade. That means if I am at this air, at this condition, the dew point is 20 degrees centigrade. That means if I have initial air, if I have the air which is at this condition, then when I cool that air, it will start condensing, water will start condensing out at 20 degrees centigrade. So the dew point of 20 degrees centigrade means this horizontal line passing through 20 degrees centigrade, and dry bulb temperature of 40 degrees centigrade. That means my air is having this composition. Do you agree, Ankush?
Yes, sir.
What is the humidity? I just have to read from the y-axis.
So
15,
15.
correct. So 0.015 kgs of water vapor per kg of dry air. What is the percent RH? 40% RH is this line.
Yes, sir.
30% RH is this line. So percent RH will be more than 30%, but less than 40%. Right? Maybe let's say just now, if I interpolate approximately, if I just interpolate approximately, this will be 40%, this will be 30%, maybe something like 33, 34%.
Yes, sir. It's
What is the wet bulb temperature now? This line, maybe put another color. This line corresponds to wet bulb temperature of what? Ankush,
yes, sir. Sir,
are
can
you
you say it
listening to me
again?
or you're not listening to me?
Sir,
I'm
listening, but
asking you a question.
sir, actually, sorry, sir, it's cracking.
This red line corresponds to wet bulb temperature of what?
Means temperature, third, s- s-
Where is it starting from?
it's 7
7.
means that's
How did we plot TWB, HWB? Where is the point TWB, HWB on this red line? HWB means 100% saturated.
yes, sir.
Ankush, you need to revise.
Sorry, sir.
Isn't this line corresponding to 25 degrees centigrade wet bulb temperature?
Yes, sir, and
This point is TWB, HWB. Do you agree or do you disagree?
sir, I agree, sir.
Uh, this line corresponds to what wet bulb temperature? This line corresponds to wet bulb temperature of 27, 28, 29, 30 degrees centigrade wet bulb temperature. So this is 26-degree wet bulb temperature. So now you tell me, this point is lying between these two lines, isn't it?
Yes, sir.
So wet bulb temperature will be what? It will be between 25 and 26.
Yes, sir.
So if I interpolate, maybe something like 25.5.
Yes, sir.
Is that okay?
Yes, sir.
Are you comfortable now? Better?
Sir, I will practice it.
Yeah, practice using humidity chart. It is easiest.
Yes, sir.
Okay. Shall we go
Sorry.
forward?
Yes, sir.
Anybody has any other doubt? Anybody has any other doubt?
No, sir.
One second. I think there is some problem with sharing the screen. I might have to log out and I might have to log in. I am unable to share the screen. So I'll just log out and I will log in again. All right. Now I'm able to share again. So can we go forward? Can we go to the next problem? Anybody has any other doubt?
Yes, sir.
Yes, sir, we can go for.
Okay, let me open that humidity chart also once again. I have to close that also. Okay, so sometimes when you are having to store products which are sensitive to water vapor, like say for example some drugs are um, sensitive to um, sensitive to how much water vapor is there. They degrade with in presence of water vapor and temperature. So some combination of temperature and water vapor you would like to maintain. So many times you would like to have air which is having a certain temperature and a certain percent RH, and this is very critical to the shelf life of the product. Many drugs fall in this category many times. So when you see drugs that you take, it always says, most of the time it says store in a cool and dry place. Have you seen any bottles of drugs, or
Yes, sir.
Yes, sir.
especially
Yes,
let's
sir.
say eye drops or things like that? It always says store in a cool and dry place. So uh, that's because of the shelf life is important. So when you manufacture these kinds of drugs, you need to ensure that in your manufacturing site your temperature and percent RH is always controlled at a given value. Or many times when you have let's say food products being manufactured, the food product will change their nature in the sense that they will feel differently uh, when your temperature and percent RH is different. So they may become more sticky, they may become less crunchy. Let's say you are trying to eat um, chips or fries, and if they are in a very hot and humid place, it just becomes soggy after some time. You feel as if you're eating a paper, and then you would not want to eat those packet of chips. So when those kinds of things are made, you need to control temperature and humidity of the air in the premises as well as during transport. So here is one problem. uh, I will just describe the problem and then we will try to solve the problem. But to solve the problem, we will need some more data, which I will give you in due course of time. Um, okay, so let's say we have we are in a cold country. So let's say total pressure is 760 mm Hg. Now, when I say cold country, let's say the climate in that particular day is cold. There's no such thing left as cold country on this planet anymore. Even places like Canada are having 46 degrees centigrade temperature. Anybody read today morning's paper?
Yes, sir. There was a heat wave in North
Yeah,
America,
people.
about 50 degrees Celsius.
Yeah, so places which are supposed to be cold are having hot temperatures. Okay, let's say temperature is 20 degrees centigrade, uh, and okay, so let's say temperature is 20 degrees centigrade, ambient air, and percent RH is, let's say, 70%. Okay, we would like to do something to this air, right? And the air coming out, of course, pressure we still want the same. Assume that it is going to be the same pressure, 760 mmHg, just to make our life simple so that we can use our humidity chart. Say temperature we want is 35 degrees centigrade, and percent RH we want as 40% RH. Okay. Okay, is the problem statement clear to everybody? I would like you to tell me whether I need to add water to this air or I need to take out water from this air. So the first question that I want you to do is whether water needs to be taken out or added. Once you tell me that, then I will tell you the next problem. Okay, use the humidity chart. We can do with using the low temperature chart. Let's just change the humidity of that incoming air a little bit. We will, what is the humidity that we've taken? Let's not take this 70% RH. Let's say RH is, say, 50%. Yeah, that's better. 70 also would have done, not a problem.
Sir, add water.
We need to add water vapor, right?
Yes, sir.
Liquid water, if I add, it will just evaporate. So that is one answer. Any other answer?
Sure, we have to add water,
Yeah, add, correct.
water vapor.
Yeah. Let's just wait for other people also to say something.
So yes, we have to add it.
So we have to add.
Yeah,
Yes, sir, we have to
Yes.
add water vapor.
yeah.
Yes, sir, we have to add.
Yes, sir, we have to add water.
Yes,
Okay.
add.
Okay, so let's see. Let's see this in terms of the humidity chart, just so that everybody is comfortable and everybody is following what we are talking about. Right, so inlet air is 20 degrees centigrade and 50% RH. So if you look at these percent RH lines, this is the 50%. Oops, sorry. Let me draw. Yeah, so 50% RH. This is our 50% RH line. Right? You agree? And 20 degrees centigrade. That means 20 degrees centigrade is here. 20 degrees centigrade. So we are here. 20 degrees centigrade and 50% RH. What is the humidity? Humidity is just above this. So humidity is 7 grams. So inlet air, 20 degrees centigrade, 50% RH. Humidity is around 0.007 kgs of water vapor per kg of dry air. Outlet air. What is the outlet air? 35 degrees centigrade, right? And 40% RH. Another place where these kinds of things become important are godowns, where you store grains or where you store wood, these kinds of places where you want to control the amount of humidity so that these pests don't grow or pests don't form or pests don't thrive. You need to control the temperature and humidity. Okay, so outlet air is 35 degrees centigrade, 40% RH. Where are we? 40% RH is this line. This is the 40% RH line. 35 degrees centigrade, this line. That means we are here, right? So we are having a humidity of 14 grams per kg. So humidity is 0.014 kgs of water vapor per kg of dry air. So this is our inlet, this is our outlet. So we would like to go from that inlet to outlet. We want to go from here to here. Do you agree with this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now tell me how. Tell me what are the possible ways that you can think of. Then I will tell you another easy way of doing it. So tell me what comes to your mind. How do I add water vapor? Any thoughts?
Sir, we can take 100 kgs of dry array of ambient air as basis and then do the further calculation.
Then calculation is one part, but how do I increase the humidity of the air? Humidity is 0.007. Humidity is 0.014. How do I actually do it? Forget about calculating. Calculations we will do. But how do we actually add
Sir,
water vapor?
by boiling water and using the steam to,
Okay, so
you
one
know,
option. Okay, so one option is add steam directly. Okay, that is one option. That's a straightforward option.
So remove dry air.
How do I remove air? I have dry air and I have water vapor. I have dry air and I have water vapor. Can you think of a way of removing the dry air? Yes, you're.
Sir, we can't without lowering the pressure then. Like,
If I do anything to that air, water will condense or not condense, or water will be the first one to create a issue, right?
Yes, sir.
Uh, do you know of any way of removing air from water vapor? Or normally,
Humidifier.
huh?
Humidifier.
Uh,
Humidifier.
so humidifier. So how does a humidifier work? Yes, you are right, but tell me how to do it. Doing
So to
calculations is.
remove to remove water vapor from dryer, we can use a efflorescent substance.
I have to remove water vapor. I have to increase the water vapor content.
Sorry, sir. Increase the water vapor content.
To remove, we have seen other previous problem. No, just cool it below the dew point.
sir, we can input a stream of saturated air at a higher temperature.
Input a stream of saturated air at high temperature. Where will you get that air from?
Sir,
Go to another country, buy some air from there, put it in a plane and bring it forward here and then do that. How do I get saturated air at higher temperature? That's the question. How are we going to increase the humidity of the air?
Sir, can we just sprinkle some water in the chamber, like so it will then mix up with the air?
Okay, sprinkle some water. Okay, sprinkle
and
some
then
liquid
increase,
water.
and then we can increase temperature.
Right. So that is one option. We can sprinkle some water. But so if I take this air and okay, so what you are saying is sprinkle some water, spray water, and thereby it will become more humid, right? But what will happen once I spray the water? Will the air also not cool down?
Sir, we'll have to maintain it at a particular temperature.
Yeah, yeah. Who was saying spray some water? Dharmik was saying, right?
Yes, yes, sir.
So Dharmik, if I spray some water, will it not cool the air?
Yes, sir. So, sir, instead we can just add a stream of water and then heat the whole mixture to 100 degrees Celsius, 100 degrees Celsius, so that whole water vaporizes and then cool it to 35. So,
That means what you are saying is you will take. Okay, what you are saying is one, take, let's say, I mean, of course, our basis suppose is 1 kg of dry air. Then take this 1 kg of dry air. It has 0.007 kgs, means 7 grams of water. It outgoing air we want 14 grams. So take 1 kg of dry air plus 7 grams of liquid water. Then heat the whole thing to 100 degrees centigrade, so that this 7 grams of liquid water vaporizes. So then we will have 100 degrees centigrade air, and that air will contain 14 grams of water vapor per kg of dry air, isn't it? Is that what you are saying?
yes, sir.
And then cool this to 35 degrees centigrade. Is that what you are saying?
Yes, sir.
So
Yeah.
another method would be combustion,
Okay, I combust what?
some methane.
Okay, methane I combust and get what? Carbon dioxide and water vapor.
Yes, sir.
But
And the excess carbon by this you are reducing oxygen also.
huh,
So to some extent you are reducing the dry air percentage, and
no,
then
no.
to
But suppose, see, this is required in a, let's say, a factory, let's say making a pharmaceutical product or a drug or a food product, let's say chips or something like that. If people are going to be working in this air, right? People are going to be working in this air. So I can't allow people to suffocate. I can't, it is not allowed to have people working in your factory with having less than 20% air, 21% oxygen.
okay.
All right. So that is not feasible. And carbon dioxide will also get added.
So that we can remove, right?
So then, but then oxygen has to be supplied, right? Then I have to add fresh oxygen. Okay, here is what we do. Here is what we do. I mean, what you have said, options are correct. You're thinking of various options to add water. One of the ways to add water is to spray water. Is to spray this water. So I will spray water the property, if you think about the wet bulb temperature, is that if I take this air and I spray water at the wet bulb temperature of incoming air, okay, if I spray the temperature, if I spray water which is at a temperature of the wet bulb temperature of the incoming air, the air coming out of this spray chamber will get humidified and cooled along the wet bulb temperature line. Think about this. Right? Think about this. Imagine, suppose you have a room, okay, and I have some water in that room. This water will be cooler than this room. Suppose this temperature is 30 degrees centigrade. This water, if I take it in a bucket, this water maybe will come to maybe 24 degrees centigrade. Why? Because there is a evaporative cooling. The temperature of that water will reach the wet bulb temperature of the air. That's why water in a bucket appears to be cooler than the ambient air, because it is at the wet bulb temperature of that incoming of that air, right? Or if you want to cool some room, what do? You spray water in that room, and then that spray, all these coolers, all the advertisements that you see on your TVs of coolers, they spray water, and then the water evaporates, air becomes humidified, but air cools down. That's how these coolers work. And I mean, that's how they don't work in the rainy season, when the outlet humidity of the ambient air is itself more than 80-90%. But they work nicely in summers, where the temperature is actually hotter, but the humidity is much less. So if I spray water which is at the wet bulb temperature of the incoming air, air will get cooled and humidified. This process we call as adiabatic saturation. And you can derive this. We are not going to derive, but you can derive this, that adiabatic saturation means it will cool along the wet bulb temperature line of this temperature, of this wet bulb temperature, right? So now tell me, what is the wet bulb temperature of this incoming air? 20 degrees centigrade and 50% RH. 20 degrees centigrade and 50% RH. What is the wet bulb temperature? Let me go to that presentation, that window. What is the wet bulb temperature? 20 degrees centigrade, 50% RH. What is the wet bulb temperature? Somebody tell me.
So 14.
14, 15.
Yeah. So this would
14.
be correct. This line would be having a wet bulb temperature of, let's say, 13. This would be having the wet bulb temperature of 14, right? So maybe the wet bulb temperature is something like 13.5 degrees centigrade, right? Okay, so now if I take this air, and I spray water which is at 13.5 degrees centigrade, I will get outlet air which is humidified and cooled along this wet bulb temperature line. Means its humidity will increase and its temperature will fall along this line. Do you agree with that?
Yes,
Sir,
sir.
may you please repeat, sir?
So if I spray this water at the temperature of the wet bulb of the incoming air has a wet bulb temperature of 13.5 degrees centigrade. So if I spray liquid water at 13.5 degrees centigrade, the air will get humidified and cooled along this wet bulb temperature line. That is called as adiabatic saturation. We are having infinite amount of water being sprayed so that this water temperature does not change. Okay. So therefore air will get humidified and cooled along this wet bulb temperature line. You can derive this for yourself, but we are not going to do that. We will do that only once we start doing energy balance, right? So at the most, outlet air will become 100% saturated. What is the humidity that it will have? What is the humidity that it will have?
Around 10.
Yeah, around,
0.01.
correct, around 0.01 kgs of water vapor per kg of dry air, right? And it will come to a temperature of the wet bulb temperature, which is 13.5 degrees centigrade, because it has now become 100% RH, 13.5 degrees centigrade, right? Now if I heat this air to 35 degrees centigrade, I will reach here. Do you agree with that?
Yes, sir.
So now if I heat it to 35 degrees centigrade, humidity will be 0.01. Have I reached my target humidity of 0.014?
No, sir.
No, that
No.
means doing this is not a good idea. What else can we do now? What other thing you can think of now? Using the same principle of spraying the water which is at the wet bulb temperature of incoming air.
So we could
Sir,
repeat the process n number of times.
Correct. We could do it n number of times. We could take this 0.01 degrees and 0.01 this air. We can again spray water and so on. Right. That is correct. Can you think of a situation like this? Okay, let me go
So
back
we
to that.
can,
Yeah.
we can spray water at a temperature uh, whose wet bulb temperature would have a humidity of 0.014.
Right. So let us do it like this. So what we will do is we will not spray water immediately. We will do it in 3 steps. We will first heat the air to some temperature. Let's find that temperature. Okay. Then we will spray water at the wet bulb temperature of incoming air. Incoming air means now incoming to the spray chamber, not this incoming. What is incoming is this air to the spray chamber. Do you agree?
Yes, sir.
And then the outlet air going out from the spray chamber, let's assume that it has 100% relative humidity. It has become fully saturated. And then we will heat this air again so that it comes out at 35 degrees centigrade and 40% RH. Okay, so I would like you to find out this temperature. I would like you to find out this wet bulb temperature, and we are going to spray water at the same wet bulb temperature. I would like you to find out the temperature here. It is obviously going to have the same wet bulb temperature. It is going to cool along the wet bulb temperature line. And I would like you to find out the humidities at all these places, percent RH as well. Okay, is that clear? We would do it in these 3 steps. So find out the temperature after the first heating. It should be such that when we spray water at the wet bulb temperature of that air will get humidified and cooled so that the outlet air becomes 100% RH and cooler, which on subsequent heating will give you 35 degrees centigrade air and 40 degrees centigrade, 40% relative humidity. Right? Use the humidity chart. Is the problem statement clear to everybody? Everybody has figured out what is to be found?
Yes, sir.
So the screen is not visible, sir.
Yes, sir.
Oh, so sorry. Something is wrong. Let me share it again. I don't know, some problem today with this Google. It's creating a lot of issues. Let me start again. Now it's visible.
Yes, sir.
Yes, sir.
Yes, sir. So again it blacked out.
Sorry. Now,
Yes, sir.
how it is possible? Now it is still visible, right? There's some issues today. Normally it doesn't create all these issues.
So one question,
Yes.
can the wet bulb temperature be lower than the dew point?
Okay, we will answer that. Do this problem, then we will answer. Can the wet bulb temperature be less than dew point? Okay, we will answer that. I want to answer, but let other everybody also concentrate on the answer. So let them finish this, then we can talk about it. Okay, shall we see the solution or you need more time?
2 minutes, sir.
Okay, okay.
Sir, do we have to say the answers or we will directly discuss the solution?
But you can tell me answer if you have.
Okay, sir. So from the first step, the T is coming around 26,
26.
and
Okay,
wet bulb is coming at 20 degrees Celsius.
okay.
Humidity is coming 0.012.
0.012.
2
How
approx.
humidity has increased in the heating step?
I will have to check.
Praveen, we are just heating, no? You're
Yes,
just
sir.
heating the air from 20 degrees centigrade to 26 degrees centigrade. So how humidity will increase?
Yes, sir. I will check.
Uh,
Wait a minute.
Hello, sir.
Yeah.
Sir, can I volunteer?
Yes. Yes. Why not? Dharmik, you are wanting to volunteer.
Yes, sir.
Okay. Many times you have already volunteered, but it doesn't matter. You can volunteer. We'll just wait for 2 3 minutes till other people finish. Then you can volunteer.
Yes, sir, sure.
Good that you are coming out with volunteering to solve. I want people who don't speak up to volunteer. Ram, are you ready? Your breakfast and all those things are done. Probably he's not there. He has gone to have his breakfast or maybe lunch, early lunch or brunch. Ram is there. Matlab,
So
virtually
the
there,
screen
physically not
again
there.
blacked out.
Pardon? Oh, screen
So
again
the
blanked out.
screen blacked.
This is so weird here. This is so weird. So today it is creating such a weird issue. Ram is there. Matlab, virtually he is there. Physically he is not there. Okay, should we see the solution? Do you need more time? No answer means you need more time.
Sir, I'm getting confused at the spraying step.
At which step? The first
So,
heating step. Or which step?
so,
Spraying spray.
yes, like, why do we need to heat it over here also?
Why do I need to what? Spray the water?
No, why do we need to heat it before spraying the water?
Because it would not reach the final humidity that we want. It would reach only 0.01, right? We saw that. If I had okay, let me go back to that. Go back to our humidity chart. So if this is our, you're able to see this, right?
Yes, sir.
So if you just spray water at the wet bulb temperature of the incoming air, you will reach only up to here. You will reach only up to this much humidity. You will reach only up to humidity of 0.01.
Understood, sir.
So you will not reach the humidity of 0.014. So you'll need to heat it first.
Okay, sir.
So Dharmik, you want to volunteer now? Or you need more time?
Yes, sir, I've done.
Other people need more time, or can we see the solution?
Sir, can I tell my answer?
Sir, I verified now.
Okay, 1 second. Let me write the. Let me open that again. Let me open the notebook again. Today I'm not able to present the whole screen. There's some problem. Okay. So what is your answer? Who was answering?
Sir,
Yeah, answer.
T is 35 degrees Celsius.
Nishant. So after first heating, what is the temperature?
35 degrees Celsius.
35 degrees centigrade. What is the wet bulb temperature?
20 degrees Celsius.
20 degrees centigrade. Okay. So you will spray water which is also at 20 degrees centigrade. And what is the outlet temperature?
35. No, 20.
20 degrees centigrade. Okay. And humidity?
Unit 0.014.
0.014. Okay.
Sir, same answer from me also.
Same answer. Okay, Praveen. So you
Just
managed to
did it different.
yeah, something. Okay. Okay. So now, okay, Dharmik, volunteer. Go ahead. What do you want to? What is your method?
Sir, like I went the reverse way, like before
Very
hitting.
nice.
Sir,
Right.
like
So the last heating step. So what we are saying is there are one heating step, and then there is a spray, and then there is a heating step, and this outlet temperature we know, this inlet we know, right? Okay. Now tell us. Now tell us. So the step
sir,
one, step two, step three. Okay. Now process one, process two, process three. Okay. Now.
sir, before the step three,
Hmm.
sir, the percentage RH will be 100%,
Correct.
and the humidity which we final want is 0.014.
Correct.
So, sir, we can see the corresponding line on
Correct.
this graph. So, sir, the temperature will be 19.2.
Correct. This
Yes, sir.
point.
Sir, yes, sir. So, sir, now we are spraying
So
water
our
before.
yeah. So our third heating step, our final heating step, what it is going to do is only heat from this temperature, say 19 degrees centigrade. It is just going to heat up to 35 degrees centigrade. So this temperature would be 19 degrees centigrade, and I'm just going to heat it to 35 degrees centigrade. Automatically percent RH will become 40. Okay, now
So now as we are spraying water, so the as we spray, the temperature falls along the wet bulb temperature. So
correct,
if we go the reverse way downside, uh, and correspondingly 7 humidity.
right,
So where both of these will intersect, we will get our initial points.
correct. That means we have to go in this direction, but to go in this direction, we are going to spray water at the wet bulb temperature of 19 degrees centigrade, and this incoming air will also be at 19 degrees centigrade wet bulb temperature. That means we are along humidifying and cooling the air along this wet bulb temperature line, and this humidity in the first heating step, which was 0.007, this also humidity would be 0.007, right? That means we have to do this right from this point 0.007 to it becomes 100% saturated. So that means we have to do this till a temperature of almost 36 degrees centigrade, right? So temperature is
So,
almost 35 36 degrees centigrade.
so can you repeat it once more?
Okay, Dharmik, repeat it once more. I'm not the one solving, Dharmik is the one solving.
I'm actually having a problem in visualizing that why are we heating it in the first place.
No, first of all, let Dharmik explain again.
Sir, like we are because before the third heating step, we want the percentage. We we want the humidity as 0.014. So we are
Correct.
taking the corresponding humidity and seeing the wet bulb temperature there. Now as we have sprayed
Okay,
water,
slowly. So this third heating step, are you okay? Whoever was asking doubt, is it okay? Is it comfortable now?
Yes, sir.
Okay. Now go back to the second step of spraying water. What is the wet bulb temperature? 19 degrees centigrade. 19 degrees centigrade, isn't it? So that means if I spray water at 19 degrees centigrade, this incoming air also must have, we want the incoming air to be at the same wet bulb temperature. So this incoming air should also have a wet bulb temperature of 19 degrees centigrade. But what is the humidity that it should have? 0.007. So this wet bulb temperature of 0.19 degrees centigrade, that means it is going to cool along this wet bulb temperature line of 19 degrees centigrade. But the humidity that it has to have before it enters the spray is 0.007. Do you agree with that?
Yes, sir.
So that means if I have this air coming out of the first heating, then in the spray it will have a wet bulb temperature of 19 degrees centigrade. In the spray it will get humidified and cooled along this wet bulb temperature line, and it will go out at saturated at 19 degrees centigrade. So the first heating step that I must do would be to take it from this incoming 20 degrees centigrade to something like 35, 36 degrees centigrade. What is the temperature here? It is some 35.8, 35.9. So let's just say 36 degrees centigrade. So I will heat it up first of all to a temperature of 36 degrees centigrade, so that it has a wet bulb temperature of 19 degrees centigrade, but it has a humidity of 0.007. Okay. Now if I spray water at 19 degrees centigrade and allow it to cool and humidify, it will get completely saturated. Temperature will become the wet bulb temperature and humidity will become 0.014. And in the third heating step, I just have to heat from this 19 degrees centigrade to 35 degrees centigrade. Is that okay? Now to answer again, Arya, your doubt. If I do this without the initial heating, what will happen? I will spray water at the incoming wet bulb temperature. Right. Arya, are you there?
Yes, sir.
So I have 20 degrees centigrade, humidity is 0.007, wet bulb temperature is, what is the wet bulb temperature? This wet bulb temperature is something like 13 and a half, 13.5 degrees centigrade. Now if I spray water at 13.5 degrees centigrade, I will get the outgoing air which will be at 100% RH. It will have a temperature of 13.5 degrees centigrade. How much humidity it will have? It will have only this much amount of humidity, which is 0.01. Now if I heat this air to 35 degrees centigrade, am I going to reach my target humidity of 0.014?
No, sir. But if we let the water come at 19 degrees centigrade, what would happen?
Yeah, so if you allow water to come in at 19 degrees centigrade, then obviously this, it is not anymore adiabatic saturation. So you'll have to look at energy balance along with material balance. So those are those kinds of things we will do as we go along. So right now we are only doing a case where we do adiabatic saturation, and we are only allowed to spray water which is at the wet bulb temperature of the incoming air. That's all. Okay, so yes, you are right. You can spray water which is at a higher temperature also. Why 19? You can spray liquid water at 30 degrees centigrade also. So air will get heated along with humidified. isn't it?
Yes, sir.
So one option is take 20 degrees centigrade air, humidity is 0.007, right? I spray water, let's say 35 degrees centigrade. Then water will give heat to this air also, and it will humidify also because this air is not saturated. So then the outgoing air will be at a higher temperature and at a greater humidity. But then to do that, we will need to solve energy balance along with the material balance. So that is something we will do later after mid-sem. Right now, we are only spraying water which is at a temperature of the incoming wet bulb temperature of the incoming air. Then it will just get cooled along the wet bulb temperature line. So we don't have to worry about the energy balance because it is adiabatic saturation. Energy balance is automatically satisfied. You don't worry about that just now. It is just assume that it gets satisfied automatically.
Okay, sir.
All right. So I will leave you with one more problem just along the similar lines. Let me go back to my notebook. Okay, let's go back to the notebook. Let's take this one more problem as homework. Right? So let's say incoming air is at 30 degrees centigrade. Let's give different things. Say dew point is 20 degrees centigrade. Say total pressure is 760 mmHg. Let's assume that total pressure is same 760 mmHg throughout. Okay, I want the air going out. One second, let me just open that problem so that I can give you some values. Yeah. So 30 degrees centigrade, dew point is 20 degrees centigrade. And I would want outgoing temperature, outgoing air to be, let's say, 80 degrees centigrade. And let's say, I'll make life a little more difficult for you so that you know the limitations of the charts as well. Percent RH is 25. Okay, we want this air to go out. Okay, again, we are going to do this in 3 steps. Heat to some temperature T. Wet bulb temperature will be something else. Spray water. At the wet bulb temperature of incoming air, incoming to spray chamber. Right? So this wet bulb temperature will remain the same as the incoming wet bulb temperature because it is going to cool. Air gets humidified. Cooled to air gets humidified and cooled along the TWB line. Okay, so I want you to find out the wet bulb temperature here as well. So this is TWB2, this is TWB2, TWB2 line. Okay, we want this to be, let's say, 90% RH. air coming out after the spray chamber has to be 90% RH, not 100% RH. So T3, and of course humidity, and then we finally heat, so that we get this temperature of 80 degrees centigrade and percent RH of 25. Okay, so that's your homework. Do this problem. Look at the problem that we did today. Okay, same lines, you will have to do this problem along the same lines. Okay, only thing is that we said this air was 100% RH. Now I am saying only that this will be, now I am saying that it will be only 90% RH. Okay, otherwise the problem is exactly similar, just different sets of values. Okay, will you be able to do this problem? Anybody
Yes,
is
sir. Yes.
anybody is not clear what is to be done? Find out all these unknown temperatures, humidity, percent RH, dew point, whatever is to be found out. All right. Now, small quiz is due. So, do you have your afternoon lecture, or you don't have your afternoon lecture?
So we have the afternoon lecture.
Oh dear. I mean, nice, good, good. I should not say that. Uh, um, when is your what time is your afternoon lecture?
So from 2:30 to 3:30, but it may be extended. So not sure till when it will end.
So, shall we again, like last time, say from 4:30 to 6?
So no, can we place it tomorrow? Tomorrow afternoon would be free.
Tomorrow afternoon you are free,
Yes, sir.
but 4:30 to 6 is not a good idea. We're tired whole
So,
day and
yes, sir.
okay. Tomorrow what time?
Tomorrow after lunch.
So shall we say 2 to 3:30 or something like that?
Will do, sir.
Okay, it's fine. I just have to put reminder for myself. So quiz tomorrow. July 2nd, Friday, 2 p.m. to 3:30 p.m. Okay. Remember why we are having quiz. We are having quizzes to help you to practice and identify weaknesses, so that you can study proper things and face the world. Okay, that is the reason we are having quiz, not to give you marks. I can submit all your continuous assessment marks now, everybody 30 out of 30 now. No, 20 out of 20, how much out of whatever is out of whatever, right? But that's not the point. Point is that you identify what you don't know and what you need to practice more. That is the only purpose of having quiz and mid-sem and end-sem. Not to give you marks and not to give you grades, but to tell you what is it that you need to study. All right. So we'll stop for the day. Quiz tomorrow will come at 2 o'clock to you. Okay, shall we stop? Anyway, let me stop recording. Today Google gave a lot of problems.